Let's go over part 2 of our fundamentals of probability lesson. So in this lesson, we'll learn to calculate an event's complement, and we'll create and interpret probability distributions. Now this is not a, hey, I like your outfit complement. This is complement with an E, which refers to the event not happening. So probability of an event not occurring. So if the probability of an event is defined to be P of A, then the probability that the event does not occur is 1 minus P of A. Okay, so what this implies is that the sum of an event occurring plus the sum of an event not occurring is equal to 1. Okay, plus not occurring is equal to 1. Okay. So what we talked about in the previous lesson, an example of this is since the probability of a family of 4 children having 2 girls and 2 boys is 0.375, we can determine the probability of not having 2 girls and 2 boys. So rather than 2 girls and 2 boys, we're talking about not having 2 girls and 2 boys. So we would take 1 minus the probability of 2 girls plus 2 boys, and that would give us 0.625. Okay, so example 1, a coin is flipped 3 times, find the probability of not getting all 3 tails. So in order to do this, it might be easier to find out the probability of getting all 3 tails and then doing 1 minus that to figure out the probability of not getting all 3 tails. Okay, so when you flip a coin 3 times, there's only one way to get all 3 tails. This is tails, tails, tails. Okay, so probability of 3 tails. There's one way that can happen. To find out the total number of outcomes, you can list all of these out. Or coin 1 is flipped and there's 2 possible cases. Coin 2 is flipped, heads or tails. Coin 3 is flipped, heads or tails. And if you multiply all these together, it deals with the fundamental counting principle that we talked about in the prep lecture. There's 8 possibilities. Okay, so the probability of 3 tails is 1/8. Okay. So then if we want to know the probability of not getting 3 tails, we would take 1 minus the probability of 3 tails, which is 1 minus 1/8. And so if we put this in to our calculator, this is 1 minus 0.125, which is the same as 0.875. Okay, so sometimes it's easier to calculate, for instance, the probability of not getting 3 tails. It was easier to calculate the probability of getting 3 tails and then use the complement to find out the probability of not getting all 3 tails. Okay. So probability distributions. A distribution represents the probabilities of the possible events, and then here are some steps to make a distribution. So list all possible outcomes, so use a table or a figure, and I'll talk about a couple different ways to do this. Identify outcome that represent the same event. And so what this is saying is, let's say we're tossing 2 coins. You could get heads, tails, heads, heads, tails, heads, tails, tails. Both of these here, heads, tails, and tails, head, represent getting 1 head or 1 tail. Exactly. Okay. And then make a table listing each event and its probability, and to double check all of the probabilities, the sum of everything of all those probabilities must be equal to 1. Okay, so let's talk about dice. Make a probability distribution for the sum of dice when 2 fair dice are rolled together. Use this distribution to find the probability of rolling 2 dice whose sum is an 8. And so on the next slide, I'll show you, I would definitely put this in your notes. The top row represents numbers 1 through 6 on a 6-sided die. 1 through 6 on a 6-sided die. And by filling in this table, you can find out all of the possible outcomes. Okay, so if you roll a 1 and a 1, the sum would be 2. If you roll a 2 and a 1, the sum would be 3. If you roll a 3 and a 1, the sum would be 4, and so on and so forth. Okay. Step number 2 is to identify the outcomes that represent the same event. And so here I've highlighted the outcomes that represent getting an 8 or rolling 2 dice whose sum is 8. And so there's 1, 2, 3, 4, 5 ways that can happen. And so the probability of rolling an 8 is 5 out of 36 total. So we can continue to do this. Let's say we want to find out whose sum is 2. there's only one way to do that, so that would be 1 out of 36. Let's say whose sum is 3. There's two ways to do that. So 2 out of 36, which is 1 out of 18. It might be easier to leave everything as a denominator of 36 for when you add these up. Okay, and you can continue this on and so forth. Let's do 7. So there's 1, 2, 3, 4, 5, 6. So 6 out of 36, which is the same of 1/6. Okay, so this would be the part of making the distribution that lists the probability. Okay, so then building the chart or building the table, we have, okay, let me point to this. So the sum of 2 dice, so if the sum of 2 dice equals 2, there's only one way to get that, and that's by rolling a 1 and a 1, so the probability is 1 out of 36. We did sum of 2 dice equaling 3, so 1 and 2, 2 and 1, that is 2, 1 over 18, okay, or 2 over 36. Okay, so this would be the distribution. We also did 7, 1, 2, 3, 4, 5, 6. So there's 6 ways, so your probability would be 6 out of 36 or 1/6. And if you add up all of these probabilities, they should equal 1. Okay. Make a probability distribution for flipping a fair coin 3 times. Use the probability distribution to determine the probability of flipping a coin 3 times and getting 2 heads and 1 tails. Okay. So for this problem, when you're listing out the possible results, I tend to either try to list them out or you can diagram them out. So if you're going to list them out, I would start with either heads or tails. So we could have heads, 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 tails, heads, tails, heads, and heads, tails, tails. So make sure you go through all possibilities if you do it this way. You could also do tails, 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 heads, tails, 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 heads, and tails, heads, heads. Okay. Another way to do this, which is a way to maybe diagram it. So I'm going to write coin 1 has heads or tails, coin 2 has heads or tails, coin 3 has heads or tails. And I'm going to use different color lines. So you could go heads, heads, heads. And then next you could go heads to heads and then down to tails. And then you could go heads to down to tails, back up to heads. And then you could go heads, tails, tails. Oh, that yellow's rough. Okay, and you could do it that way as well. So diagramming it out is another way that would work. Okay, and then so for this problem, I'm going to talk about the probabilities in terms of, we'll wait till we get to the distribution. So let's deal with the events that are the same. And so in this case, the probability of getting 3 heads would be the same event, and there's only one way to do that. So heads, heads, heads would be 1, and there's 8 possible ways. So let's say this is 3 heads. Let's talk about the probability of getting 2 heads, and I'll change colors. So 2 heads, 2 heads, 2 heads. So this would be 1, 2, 3. So that would be 3 out of 8. Let's talk about the probability of 1 head. It would be 1, 2, 3. So 3 out of 8. And then let's go no heads. Would be 1 way, 1 out of 8. And if you add all these up together, 1/8 plus 3/8 plus 3/8 plus 1/8 would give us 1. Okay, so that's how we know we've accounted for everything there. You could have done this in terms of tails as well. That question didn't really specify. So you could have said 3 tails, 2 tails, 1 tail, 0 tails, and so on and so forth. Okay, so to make a distribution now, we have a vertical and a horizontal axis. I'm going to talk about this in terms of number of heads and the probability. Now the highest thing I go up to is 3/8, so I'll probably do this in terms of 1/8, 2/8, 3/8. Okay, and so let's see, we have the probability of getting 3 heads was 1/8. 2 heads was 3/8. One head was also 3/8, and then no heads was 1/8. So that's what our distribution would look like. Okay. And then the rest of the problem says getting 2 heads and 1 tail. So if you're flipping a coin and your only options are heads or tails, we're looking at this 2 heads right here. It would be a probability of 3 out of 8. Okay, so if you have any questions, please feel free to reach out to me.